greatest common factor. In your table of contents, I want you to put 4-2, greatest common factor, and everyone should be on page 27. Everyone should be on page 27. Is there anybody that is still writing in their table of contents? All right. Now, I don't want you to write anything else right now because I do want to talk about our indicator for today. And the indicator for today is a big indicator, but it has about 4 smaller indicators underneath. So the big indicator says find common factors and multiples using 2 whole numbers. So what we're doing today is the first little one underneath. Compute the greatest common factor of 2 numbers, both less than or equal to 100. So are we going to do 105? No, because it needs to be less than or equal to 100. So I want to talk about what these words mean up here. What does the word greatest mean?
The highest.
The highest. It's the highest. What does the word common mean?
Most found.
What?
Most found.
Most found. What do Ava and I have in common?
Blonde hair.
Same color hair. What else?
Well,
We're both girls.
Should I have long sleeves on?
We both have long sleeves on. Both have long pants on. So common means, in this sense, it means same. Okay? The highest same. And on Thursday, we talked about what the word factor means. And what does factor mean? Go back and look. It should be on page 26. What is a factor?
two numbers.
So, the highest same factor. Okay? I'm not going to change that word factor because I can put the highest same numbers being multiplied. Okay? So, if we're talking about what they have in common, I want the highest factor that 2 numbers have in common. That's what we're looking for. Okay? So, if you will look at that sheet that I gave you, I want you to tape it on page 27. And GCF is short for greatest common factor. And greatest common factor is the highest factor 2 numbers have in common, or the highest factor that is the same for 2 numbers. So I want you to tape that paper on page 27, and I want you to write the definition for GCF. Write it on that. Everybody should be writing it on that paper. Jenna, you need to write it.
I already did.
you were taught to multiply, you may have been taught how to create an array. You may have been taught how to use the lattice method. You may have been taught to draw dots. However you were taught to multiply. You were taught several different ways to multiply. How many people remember that? Kinda. In 4th grade, you were taught several different ways to divide. Okay? And now, how many ways do we use to divide? One, the traditional way. Okay? There are several different ways to figure out the GCF. We are going to use 2. Okay? One method, almost always. Okay? And the other one we can use as a backup. Okay? One of them is just what we did on Thursday. We're going to make a list. So we're going to use the numbers 36 and 48. So I want you to make a T-chart with 36 and 48. If you remember from Thursday, when we list all the factors, we have to list what we multiply each one by, okay? So, 1 times what is 36? 36. It's even, so that means we can multiply 2 times something. 2 times what? 18. 2 times 18. 3 times what?
6.
9. 8.
12. 3 times 12. 4 times
8.
9. It doesn't end in 5 or 0, so it can't be a 5. 6. 6. Now let's do the same for 48. 1 times what is 48? 48. 2 times what is 48?
24.
3 times what is 48? 16. 4 times
12.
12. It does not end in 5 or 0, so we can't do 5. What about 6?
6.
8. 6 times 8. And we're done. Okay? So, now we've listed the factors, but we're trying to find the factor that they what? That they have in common. The highest number, the highest factor that they have in common. That's what we're looking for. So, it can't be 48 because this is 36. Okay? So, is there a 36 over here? No. Is there a 24 over here? No. Is there an 18 over here? No. 16 over here? No. 12? Yes. So, the greatest common factor is what? 12. The highest number that they have in common is 12. Now, listing factors can be tricky because if you have been doing this without my help, I bet we would have missed this one. Be honest, how many people knew that 3 times 16 was 48? You didn't, did you?
I knew that 4 times 12 was 48.
You knew 4 times 12 was 48, but we would have missed that one, okay? So that's why listing all the factors can be a little bit tricky. So there's another way.
The other way is using the ladder method. And the reason it's called the ladder method is because it looks like rungs on a ladder when you get finished. Okay? So, oh, I didn't want to do that. No, I want to stay there. And then I'm going to flip it. And if you're on your Google Slides, I'm going to switch. I'm not doing 6 and 12 right now. I want to do 36 and 48 to show you that it does work. Okay? So, on the left side, I want you to write 36 and 48, and we're going to do the ladder method. You just have to do it at the bottom on the right. The first step says to write the numbers down and draw a step. That is what a step looks like. It's an upside down division sign. Okay? It is an upside down division sign. Now, pick a prime number that we can divide both of those numbers by. Pick any number. What can I divide 36 and 48 by? 3. 36 divided by 3 is 12. 48 divided by 3 is 16. Now, what can I divide 12 and 16 by? 2. So I'm going to draw another rung on my ladder and put a 2 over here. How many times will 2 go into 12? 6. How many times will 2 go into 16? 8. Now, what can I divide 6 and 8 by? 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Can we go any farther? No. Now what I'm going to do is I'm going to circle the numbers on the left. Okay? Circle the numbers on the left. And we are going to multiply these numbers to give us our GCF. 3 times 2 is 6 times 2 is 12. Did we get the same thing? Yes. Was this easy?
Yeah.
Yeah. Way easier than listing all the factors. Okay? So, now let's try 6 and 12 and see what we get. So I want you to write 6 and 12. What can I divide 6 and 12 by? 6. 6 divided by 6 is 1. 12 divided by 6 is 2. Can I go any farther? No. So, my GCF is 6. Would you like to try another one?
It's kind of like backwards division.
15 and 45. They both end in 5. So what can I divide those by? 5. 15 divided by 5 is 3. 45 divided by 5 is 9. Can I stop? No. What can I divide 3 and 9 by? 3 divided by 3 is 1. 9 divided by 3 is 3. Can I go any farther? No. So, 5 times 3 is 15. It's easy peasy, right? Yeah? All right, we do have an exit ticket, but we're going to wait for just a second, okay?